good. Sound is perfect.
Yes.
Excellent. I gotta say, sometimes the headset works out well. So this is my little talk. I hope everybody enjoys it. Anybody has any questions, by all means, I'll be keeping an eye on the public chat a little bit, and we'll kind of go from there. I was thinking about changing my introduction because I was talking to a friend the other night, and he's like, can you describe bin format MISC in detail that interests me in a non-programmer? And I'm like, I highly doubt it. But I kept going back and forth, and I eventually came around to the concept of the Jeff Goldblum movie, The Fly. One rule bin format does for your Linux system is it makes it go a little bit crazy, so it understands different types of files, so it can do different things with them. So you can have it do all sorts of weird, funky things that it normally wouldn't do by default. So you're just telling the system, hey, I'd like you to take a different shot at something, do something different with this. I'd like you to have it do this kind of thing. So it's a very cool little tool. It's been in the kernel for quite a while, but let's go ahead and talk about the regular parts of my introduction. Everybody loves esoteric languages. If you haven't played with LOL code, you should. It's a lot of fun. It's Turing complete, so it's a real language, as people would say. It's you can do a lot of stuff for you. I mean, there's a bunch of different languages out there that are kind of in that same whole space, like Arnold C. If you haven't tried Arnold C yet, I highly recommend it because you should always try and get to the chopper. So it's very good stuff. But the question is, how do you run some of these programs without having to always put the interpreter on the command line? So that led me down this whole rabbit hole, which led to this talk. If you look at the Linux source code tree, there's Linux supports 6 types of formats directly, 4 executable types, 8 out. If you've been doing kernel since like I have been for many, many years, you'll remember back in about 1995, there was a huge, I would use the term holy war, is not probably an understatement, between moving from the 8.out format to the ELF format, because there was a whole lot of stuff required to rebuild the kernel. I remember the Slackware guy, Volkerding, kept talking about it, and I can't remember. I think he said eventually, "Welcome to hell. Here's the ELF version of Slackware." So it's put on a lot of effort over the years. But the 8.out is still in the kernel. It's getting deprecated in the newer versions and stuff like that. But there's those four basic types. There are also 2 interesting types that are referred to in the kernel source code: scripting and miscellaneous. So a little bit more about the executables. There's a file called bin format 8.out, which understands the 8.out format. There's bin format elf, which understands the elf format. Bin format elf, FDPIC elf format, which is position independent code. And there's flat binaries, which is just a file without a header or anything like that. And it's just executable instructions. And so it's kind of interesting. And there's bin format misc.c and bin format script.c. Well, let's ask the first question. If this already exists, why do you have to write it? So is bin format script the answer? Bin format script sounds promising. We start looking at the source code for it. It is a way to call scripting options. However, it has some limitations working for our example. It expects every file to start with a hash bang or a shebang, and then the interpreter name or an environment that then calls it after that. So that's kind of a little bit of a pain. Why this won't work for me? Here's an example LL code program. I 1.2 and has standard IO question mark visible hi world bang 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 1 bang. By the definition of the language, every LOL code program starts with hi, then the version number. There is no real way to get a bang as the first line in the first character. The comments, normally a lot of systems with scripting language, you can use they will use the hash as the beginning of a comment. Well, LOL code doesn't do that. So you end up, it's BTW, then the comment. So that won't work for us either. So there's a couple of different potential workarounds on that. You can modify LL code to support shebang and change the interpreter and modify all your programs that you like to play with. Thank you, no. You can write a helper program with a bang question mark at the top that will call the LOL code interpreter and then run it. That sounds complicated too. There's a example being the Go guys. There's a program that will take your it's called Go Run that will provide this capability. You can actually put the bang character at the top and it will actually invoke it. So there's ways around it, but then you're also changing the format of your programs. You're having to run additional stuff. I don't like that. You can also name a convention where all files and an extension like LOL and writing an alias to execute it and stuff like that. But you're back to the point where you're having to do stuff you shouldn't have to do. It should just be able to be done. So all those options have some pain involved. So let's take a look at what bin format MISC does. If you look at the format, the Wikipedia page for bin format MISC, it sounds great. It sounds almost exactly like what we're looking for. Bin format underbar MISC, miscellaneous binary format, is a capability of the Linux kernel which allows arbitrary executable file formats to be recognized and passed to certain user space applications such as emulators and virtual machines. That sounds like what we're looking for. So the next question is it enabled on your machine? And that's not too hard to find out. You just do find mount bin format MISC and see if it shows up. There's some other ways to do it as well, but I just went with the simplest way because I was just trying to figure that part out. So let me try and switch to my screen. Can everybody see my screen? Hopefully.
Yes. Can you make the font a little bit bigger?
Actually, let's see. Come on. Yeah. That any better for you guys?
A little bit.
Okay. Well, that's about as big as I can make it, unfortunately.
Well, I don't know. Maybe it's me.
Oh. Actually, I was just trying to compile up Mateus's code because I was kind of curious about it. So here we have a simple lolcat program. Hi 1.2, can't have studio, visible hi world, K thanks bye. So if we try and run it, we're going to get the following. It's going to try and interpret every line as though it's a command. It's going to assume it's just a shell script, so it's not going to work for us in that component. So that's not great. Now let's go ahead and try and run it as a regular. I've already installed the interpreter, so if I just do that, then a.lol, I get hi world. That's great. I mean, that works from that component, but it doesn't work the way I want it to work yet. So that is the next step. Oops, that's one skip ahead. So we need to register the format with bin format MISC to know what to do with the executable. There's 2 ways it supports doing it. Number one is by file extension. It's if you have a naming convention where you name all your files .lol files, it'll use LCI to run them. The other way, which is the way that we'll be talking more about later, is by magic header, which is for files again with hi, use lolcat to LCI to run them. So let's go ahead and add the file extension to bin format MISC. The register file contains lines which define the executable types to be handled. Each line is the format, name, type, offset, magic, mask, interpreter, and flags. Name is the name of the binary format. Type is either E or M. If it is E, that's an executable file format identified by the file name extension. Magic is the file extension to be associated with the binary format. Offset and mask are ignored. Yeah, and there's also flags, which is an optional string of letters, each controlling a certain aspect of the interpreter invocation, but we don't need to use those for our example. So to set it up to register this, all we have to do is tell it to care about this. Let me share again. Now we are registering it. Now there is a registered string for lolcat, which I should have called it lolco, but I didn't. Goes by executable. It knows that the extension, it goes by extension. It knows the extension is lol. It knows to pass to the user bin LCI. And the OC is just a couple of flags I picked up somewhere along the way. So now, please work. And it does work. So now we actually know about this format. We've extended the Linux system to handle this format and to understand it and have an idea what to do with it. It now knows what to do with it. We've got a couple other ones on here, blol and stuff like that. This counts from in your loop, up in your var. I do love this language more than I should, to be honest. But that gives you an idea of what it can do from that standpoint. So we had success. Come on. Next slide. Yeah. So it's registered in the system. Where is it at in the system? And the answer, as with almost everything in Linux now in the last 20 years, is proc. So in this case, it is in the proc sys bin fs bin format misc folder. Let's go over and take a look at that again real quick. The proc sys fs. And if we look there, we will see there is a little file called lolcat. There's also a whole bunch of other files in there because I've installed some other components on here as well. A couple of the interesting ones people might find interesting is the C compile, which lets you run C or C++ programs as shell scripts, which is kind of cool in its own right. The jar wrapper actually lets you run jars at the command line. There's the wine one, which invokes wine, boo. And there's a whole bunch of QEMU ones, which actually transparently invoke the QEMU emulator, which we'll talk a little bit more later. But that gives you just a quick idea of what it can do from that standpoint. Actually, let's just do a quick dump of the jar wrapper just for funsies. It shows what it invokes there. You know, telling what to do, all that kind of stuff. So we've extended it in a way that's just not standard with it. So that's great, but I don't want to have to name all my files .lol. I want it to be able to do it by the magic because that has a lot more capabilities for me when you're dealing with binary executables and stuff like that. You want to actually do that components. So the first thing we need to do is we'll need to deregister our current extension we have. Let me share the right one. So we have now deregistered. So if we take a look in this directory, the lol code is gone. And if we go back to our demo directory, we get the previous behavior, which we expected. So it's all very good and all. So next up, we need to register for the lolcat by magic. If you see the string is pretty much similar, the main difference is we do it by M for magic, and we actually put the code at the top for high, and works pretty well from that standpoint. So let's go ahead and register this bad boy. And it works by magic now. So we head back over to proc sys fs in format misc. We have lolcats back. It's set up differently now. So it knows it's doing by magic. It has the hex code values for that. So So that's great and all, but one thing we don't have right now is we don't have persistence. We've been able to add the extensions, you can add and remove, no problem. They won't persist right now between reboots. For that, we'll need to add the file to the system so it reboots. On Debian, this is under var lib bin formats folder. So let's head over there. We have a whole bunch of stuff, but we don't have an entry for lol right now. Let me scoot that up just a bit. I should have put this in my buffer, but I didn't. So there's a file now in format, which is this format, which does a lolcat magic, the offset, the magic string at the top, and what interpreter call. So now if we go ahead and reboot the box, and we wait for a minute, hopefully, or less. It's still coming up for a minute, because that's the way life is. Yes, we've now made this persistent. We've extended the system to understand this, have it persist between reboots, and it's not going to go anywhere for us, which is kind of what we're looking for there.
One question: do you know by chance how the distros Debian in particular handle this for different packages?
Debian, I've mostly been going through the Debians on this. The Red Hat stuff had its stuff. I think it was the same format. Actually, the way I had to figure this out was I actually ended up doing a dump from all the provided packages from bin format MISC. Well, actually, let me show you that, guys, that real quick. Oh, I actually ended up installing the bin format MISC support, which is how old I figured out where that file needed to be. But if you, it works, it's pretty much the same. There's a var lib systemd for bin format MISC. So that should actually be standard on all systems for systemd.
Okay, so the packet, there are those like wine bin fmt and whatever bin fmt. Okay.
Yeah.
Okay.
Yeah. The bin format support is the main one you need for any package for that. The systemd has extensions for it, because we all know systemd is eventually going to take over everything. It's just a matter of time.
No, it will not. No, it will collapse first.
Systemd will be the kernel eventually. We all know that. But that gives you an idea how old that component works. So what we were able to do here is actually extend the Linux kernel in a very simple way to not have any real problems built to handle this for us. So yeah, that's my persistence. So yeah, for that content of that file, it's just the colon separated line spread out over 10 lines. So it works pretty good there. So what this shows is you can extend the kernel to do just about anything you want to. Linux system, any Linux system that is modern. I mean, we're talking probably kernel like 4.0 on, well, we should be fine with. So we can do this. But let's do something more interesting that's more binary format, more appropriate for the Binary Tool Summit. So what we're going to do, and I've already set all this stuff installed already for the most part. Hopefully I've got it all installed. It'd be a lot smoother if it is. So what we're going to do is we're going to create a Spark 64 executable on my AMD 64 system, and we're going to run it transparently to the user. This is where the fun really begins, because you opens up a whole lot of different capabilities in terms of transparently being able to invoke. You've got a little custom DSL that has its own Java runtime or something. You want to do something groovy, Grails. You want to do something, anything you want to. You can do it if you know enough to tell it how to register and how to pass this program to user space to actually execute. So first up, of course, you need a program. Always have to do hello world. It's just the way of things. So actually, I wonder about that. Go back. Boom. So we've got a very simple program here. Cat a.c. It's what we know. It's what we love. A.c. Out. We do a file on it. It is a regular 64-bit executable for an x86 64 system. That's all wonderful, but that's not what we're looking for. We want is a Spark executable. Now, if we run file against this, we see it's an L64-bit executable, Spark v9, Sun Ultra Spark, 1 extensions required, relaxed memory ordering, version 1, statically linked, da-da-da-da-da. And of course, if you try and run that on just a regular system, you're going to get no success. But if you try and run an R system, you get it to work transparently behind the scenes for you. And how does that work? That's where things get interesting. Let me go back to my slides. Come on. Yeah. Actually, on this one, I was using GCC 11 because I was running Debian testing. But as we should know by now, the answer lies in the way that the proc system bin format MISC is laid out. Let's go take a look at that. And there's a wonderful little program on here called Spark 64. And if we look at that, it is the same as our regular style format. It's enabled. It's an interpreter that calls the QEMU bin format version for Spark transparently behind the scenes to us. It's a proof of concept, offset 0, little magic flag in the mask, and that's all you need to actually be able to do that. So theoretically, you can run just about anything you want to on there without any real big problems. There's going to be a catch we'll talk about in a minute here, of course. Oh, next going to be on that. So let's go back to taking a look at this again. You noticed I pulled a small trick that I didn't tell anyone on for the most part on this when we're doing the demo. You always have a little bit ready. I cheated to use -static. So I created a static executable. And if I do the Spark, that works just fine and dandy. But if I take static off it, and I do a file a.out against it, and then I go ahead and try and run it, I'm going to run into problems because I don't have the libraries installed for it that it needs. You can go ahead and install the alternate architecture packages for that if you want to, because you'll end up with a whole bunch of little things you'll need. Actually, it's not even going to give me that because it's not a dynamic executable to it. But it gives you an idea of what you can do. You can install multiple architectures on a Debian system, a Red Hat system, Fedora, any of the major ones without it being a big problem. But you end up going down a whole rabbit hole of types of issues. But the ability to create a static executable and have it actually be able to execute itself transparently behind the scenes is pretty gosh darn cool. And this works theoretically with any of the architectures you want to run that are supported by the QEMU. Let's go take a look at those. So if you're unlucky enough to have still have to run COF binaries, you could theoretically add them in here. QEMU can run Alpha, ARM, ARMEB, HPPPA, some weird ones in there. But it goes back to the whole concept of what it can do. It's doing this by passing it to the user space without the kernel actually having to do anything besides be a pass-through for it. It just has to know enough to be able to actually make this happen for it. So that just gives you a quick idea of what it can kind of do. There's what you can do with this. Once you can figure out, if you have the ability to get to a magic value or an extension, you can make the Linux kernel run anything you want to. And set up to do anything in terms of how complicated you want it to be in terms of trying to run stuff. If you've got a situation where you've got the ZX81 programs that are dumps of cassette tapes, and you want to actually call it an emulator for the old-time Sinclair 1000, you can do that by coming up with the right magic value or going by an extension behind it. There's all sorts of capabilities. This opens up a whole world of things to have the kernel do for you to actually make it simpler for the user to not have to know anything, to invoke anything, just it has to be able to do this additional capabilities. There's a lot of things that can be done with this. One of the ones that is really good is the guys at Cloudflare did a really good talk about how to use Go as a scripting language, because Go is fast enough that you can compile it pretty much behind the scenes, run it without it being a real big problem for a lot of stuff. And they were trying to figure out how to get this to go in a consistent manner. So they figured this part out. And I have the reference in this doc as well. Oops, opening tabs. Yeah, using Go as scripting language in the language by Cloudflare. Highly recommend this. These guys really did a great job laying out some of their components on this. But if there's a language that you consider to be a mainstream language that should exist in this space that has some capabilities, definitely something you can add to it. Another one, transparently running binaries for any architecture in Linux, the QEMU and bin format MISC. Another great resource. I used some of their stuff. They helped me figure a couple things out that I was having some issues with, because I was trying to do this without the static initially, and it was pulling me down the whole part. And I started installing a whole bunch of chroot type things in there over time, and it just did not really go well. So I learned quite a bit from them as well. But there's that. There's the Wikipedia page for bin format MISC is actually pretty good. It provides links to like the Wayback Machine for where it's at. And of course, as they always say with Linux kernel, the documentation is in the kernel website. So it's laid out there. It's pretty straightforward. I think it's actually a pretty cool thing. So, one question I did have from some people was, does this exist on other systems? I don't believe so. There was a project called Ingact Linux, which is a project to add similar functionality to Mac OS X. It looks like it hasn't been around for a while. It hasn't been updated for some time and stuff like that, but the capability exists. I mean, it's not really that difficult. I mean, from the standpoint to just theoretically be able to grab that type of code, and if you can actually have some place where you can actually add the source to it. I'm sure the FreeBSD, I don't believe the BSD guys have an equivalent to it, but if they could definitely add one without it being too big an issue to their stuff as well. So that's about all I've got on this one. So what we've shown is the way that you can extend Linux to do almost anything with binary programs. The ability of bin format MISC allows you to call a user space program to handle almost anything, to do all sorts of weird stuff to it. I'm hoping a few of you will think, hey, I could try this, I could do this other thing. It will give you some capabilities and stuff like that. So that's what I've got. Thank you all for listening. Anybody got any questions? We got plenty of time. Okay.
Okay, I think I have to be honest, I did not know about this capability of the kernel. Of course I knew about the shebang, and this and that, but I actually did not know about this support. Yeah, okay. I was looking when you was doing the presentation about how Debian packages those programs, and also I noticed how they use the magic number to actually match the e-machine entry in the ELF header to identify if it is a Spark or if it is different kind of executables.
Yeah.
Okay, there is a question in the chat.
Yeah. I don't know who wins in that situation.
But let's find out.
Yes, we got the time.
Yeah.
So let's actually just, oops. All right. That is a great question. All right. Let's go ahead and register the first one. Oops. And let's go ahead and register the second one. We'll just register it with the wrong name, so we'll know. Actually, yeah, that'll tell us. If I call it LCI 2. It won't let me register it twice. But if I give it a different name, lolcat 2. Yeah. Just file our directory, so it looks like the lolcat. It looks like magic wins over executable type, which would make sense. But I'm sure they give that higher priority.
Is it a magic or maybe it's last format that was registered?
That's definitely a possibility as well. Well, let's go ahead and register another one. Of course, we could always go to the Linux kernel and read the code to figure this out as well, but lolcat 3. Do LCI 3. Well, actually, I have to do LCI, so it'll still go. It does go by the last registered. That makes sense because it's building the table internally in the memory structure. Huh. But it offers a great deal of capabilities. I'm just not sure if there's a... Actually, let me do a quick search for this. Yeah. But if you're a Debian package maintainer, they use this as one of their ways to help them do some of their work as well. So it's... Go back. What I thought was interesting was... Yeah, the LWNet Linux Weekly News guys have an old article about how programs get run, which is actually pretty good. Talks about a lot of those components. Goes through a great deal of information on there. I learned a great deal from this article as well when I was working on some of this stuff. So, come on, a little faster wouldn't hurt. The archive slow is going to be a little slow today. Yeah, this goes back to 21XX. So it's been around for, it's been available to us for quite a while. So nothing that we haven't had the chance with. But gives you an idea to how to make your system go a little bit crazy and just try and figure something out that it hasn't done before. Hopefully somebody gets an idea of some of the other things this thing can do, because I think it offers up some capabilities. If you are in terms of running emulators or your own language or something like that that has different behaviors and stuff, you want to actually make it behave the way you want it to. Of course, you have to put a plug in for Arnold C. It's just kind of interesting capabilities. Yeah, by all means.
Yeah. Not question, comment. We had a problem in PowerPC 32-bit when releasing the POC 2 version 0, and we wanted to debug it. But there were no any. The PowerPC 32-bit is not longer supported in Debian, so. I want to share my experience. I downloaded fortunately, Void Linux has a root file system for that. So I downloaded it. I installed this stuffy tool. And the tricky thing is I used systemd and spawn, which is a container environment. It's it's a better change root actually. And you go there and do your debugging and things sound very native. And there was a problem in some executables uses different ABI in the ELF. So thanks to POC, it was very easy to spot, and I changed my configuration to support them. Thanks for your talk. That's it.
You know, I believe there might be an open slot tomorrow. I would love to see a demonstration of how you did this.
Oh, I can show it. Yes, I think we have free spots. Maybe I could show it. Yes.
Yeah, that would be very interesting to see. But it's just some weird capabilities, which is just something I came across this years ago when I was playing with some stuff, and when I was actually using something with wine. When I was still thought wine was going to maybe work for me. So, but it's just a cool little tool for doing binary type stuff. So
yes. And for people who really don't have the luxury of using Debian, we can use this. I think any container system can help them. Yes. And again, thanks for your talk.
Excellent, thank you. Cool. Well, Jose, you mind if I turn it back over to you? Uh-oh.
Okay, so thank you very much, Aaron, again.
Thanks.
And now maybe we can have a break until the next talk, which is going to be boring and long. And so let's meet again in 15 minutes. Okay. So